and welcome to the Madison Technologies Broadcast and AV YouTube channel. My name is Cameron Lucas, and today we're going to be talking about the Audio Roper Induction Loop Designer software. This is a software service that is provided by Human Technique Audio Roper to assist in the designing of hearing augmentation loops. So this software is web hosted. You can get into this software via audioroper.transim.com, and you can register for an account so that you can do your own loop designs. So the first thing that I'm going to do while we're doing this is I'm going to log in. I already have an account. I already have some designs which are stored. So I'm going to log in. You'll see here that on the login page, there is also the ability that you can apply for access. Please flag yourself as from Australia so that your request for access comes through to us here at Madison and we can approve your request. I'm just going to log in here. And you'll see that now I have the ability that I can start my design. When I click on Start Your Design, I'm now transported into the Loop Designer. So the first step of the process here is the Room Designer. You'll see here that it says to continue in the tool, you need to have at least one loop and one wall. So if you don't have a plan to work from, you can actually draw it up in here without that plan. You'll see here that we have the ability on the left-hand side, we have a catalog of objects that we can choose from. You'll see that with the walls, we have the ability to create a rectangular room or a free-form wall. We have the ability to add in objects such as windows and doors. Then there's floors, listening regions, and loops. The most important of these is the walls and the loops. For today's example, we're going to start off with a very basic room, and to do that we're going to create a wall. So if you click on the rectangular wall, that's now selected, and I need to click on a space to draw this from. This is just a one click to start. You don't need to drag this along. So as I click once, you'll see that now I'm starting to draw the loop. Sorry, I'm actually drawing the room. You'll see that my segment dimensions are up above, and I can draw the room to the size that I need it to be. So we may have a room in this instance that could be, say, 7 by 6 meters. Click again to finish, and I can scroll down the page a little bit to see all of my room. Over on the right hand side here, you'll see that we have different tools that we can select. So there's the ability to have a measurement tool. So if you want to draw a room like this and then put measurements on it, we can click on the little tape measure. We can choose one wall of the room, drag this across to the other side, and now you'll see that a measurement there has shown. This is useful when you're sharing these plans with somebody else. Now that we have a room, we can specify what the floor is made out of. Now this is a very important step when it comes to loop design. The floor has a very large impact on how the loop performs. To change the floor's properties, we need to click on the wall segment. We can right click and we can choose Edit. And you'll see here that we can change the height of the wall, the thickness of the wall, the extrusions and the thickness of the wall here, the material of the wall itself. So if you've got a wall that has a large amount of metal in it, this is of concern. For the most part, we can consider that there is no metal in the walls. Now the floor is the most important aspect here. And you'll see here that we have a few options when we click on the material. We have light steel reinforcement, strongly reinforced, no metal, strongly reinforced with a screed cover, hollow with a steel grid, or if the floor is actually metal itself. In most instances, you'll find that the first three are what you'll use. So lightly steel reinforced is typically used in a more domestic style application where you have a steel grid in a slab, but it's only going to be single story. Strongly reinforced is what you'll typically find in a multi-story commercial construction, and no metal is obviously a wooden structure. I'm going to choose strongly reinforced. We can specify the thickness of the slab as well. I'm going to now choose Apply. Nothing's changed here in my drawing, but it has changed the materials that this floor has been made out of. I'm now going to choose the loop. Because my room's rectangular, I'm just going to use this rectangular style loop. I can choose whereabouts I want the loop to start from. And just like the room, I just drag it out to choose the area. Now the target, typically with a room like this, is that you want to cover 80% of the floor area with the field that is generated from the loop. When I click again to finish the loop, you'll see that I now get to specify the type of loop. And there's three types of loops that we can use. There's a rectangular loop, which is just a perimeter loop. We have a loss loop, which stands for low overspill. And we also have a compensation loop. A compensation loop is used if you want to prevent spill in a specific direction. This is great in an application like a concert hall, where you want to prevent spill of the magnetic field onto the stage area. The low overspill loop is designed for areas where privacy is a concern, and it's also effective when you have a large loop in an area with a lot of steel because you have better control over the magnetic field. In this instance, I'm just going to use a perimeter loop, and now I'm going to choose to create the loop. You'll see here I get to specify how much current is in the loop, whether the phase of the loop is going to be at 0 degrees or 90 degrees, whether the loop is on the ceiling or not, and the elevation of the loop itself. In this instance, the loop is on the ground. I'm only using a single loop, so the phase is not important, and it's not in the ceiling. I can choose apply. Now you'll see I have a loop now specified within my room. At this point in time, I like to change the location of the starting crosshair here to where the loop starts. To do that, you can click on this little four-way arrow, and then you can click on the starting location. What this is useful for is in the magnetic field and in the part selection segments, it will tell you how far these distances are from one section of the loop to the next section, so you know you need to run the loop, say 6 meters before you need to turn the corner and then move along. Now that I have my wall and my loop, I can now have a look at the magnetic field. So here's my magnetic field. You'll see here that I have the ability to change my field plot offset. This is how much around the room is rendered, and the Z position. So this is the listening position. 1.2 meters is typical for a seated position. I have the field properties, so I can specify how much current flows into the loop. I've got a scale option here, and it tells me here that my maximum loop strength is minus 7 dB, and my minimum is minus 40 dB. The target for the loop is to get the maximum field to be plus or minus 3 dB. Like it says here, the target is plus or minus 3 dB. We're well short of that at the moment. So we can start adding more current into the loop to bring up the field. If I change this to be 10 amps, then I can click on to reset the zoom, and you'll see that now I have a large section inside the room which is now green, and the green area denotes that it's plus or minus 3 dB. You'll see here I'm still under 3 dB, so I have some headroom here that I can push more current into this loop to cover more area. If I change this to 11 amps, you'll see that the field has grown a little larger. I'm now at over 0 dB, and I've got the room quite well covered. You'll see here on the left-hand side that it also shows that my magnetic field intensity in 2 different planes. Once I'm happy with the magnetic field, I can move along to the next section, which is the part summary. In the part selection, you'll see that I have a choice of different amplifiers. I have a choice of a different wire cross-sectional area, and then it gives me data around the loop. The amplifier selection here is limited to only showing me the amplifiers that are a practical choice for this loop. The ProLoop DCC is no longer available, so the default choice is the ProLoop DCC Plus. This particular amplifier is good for 12 amps, and it has a DC minimum impedance rating of 0.5 ohms. You'll see that the loop data here shows that I need 11 amps, and using the 0.75mm round cable will give me a 0.55 DC resistance. This is within the specs of this amplifier. You'll see there is other choices of loop cables here as well. So we have the option for a flat copper ribbon tape. However, this here pushes the DC resistance to be very low, to the point where the amplifier will not be happy and will be forced into a fault status and will not operate. However, with 0.75mm cable, that's quite acceptable. If I go to the next segment, which is the summary, you'll now see that I have the design summary. It tells me about my room size, my amplifier selection part, how many loops I have, how many amplifiers I have, the specific wire cross-section. I have the loop details that we saw before, and as I scroll down the page, you'll see that there's a layout here. The layout shows my room. It's got the measurement on it that I also inserted, and now it has the details of the loop as well. So this is where the 0-point reference comes in handy. So you can see here that this loop is 6.5 by 6.5 meters, so you'll see here that it has those dimensions. It's got the field plot as well, so you'll see the intensities of the the X and Y axis, as well as the field plot. You'll see at the top of the page, you have the ability that we can download the PDF. If I download this PDF, it will just create a PDF of this design summary that we have just seen. You'll see the PDF is now downloaded. If I open up the PDF, we have our design summary in the same way that we saw it. However, now it's portable, and I can email this to anybody that needs to see it. If you want to keep your design, you can choose to save your design. I can call the design what I want to do. Sample design for loop designer demo. I have the ability that I can specify notes. So this was a 7 by 6 meter room with perimeter loop. I can save that, and when I log into the Room Designer next time, I'll be able to open that design again, and I can come and see the specs. I can come and download the PDF, or I can make changes as needed. So thanks for watching, and in the next section, we'll be talking about drawing a loop with your own plan. Okay, thank you.